Welcome to CLI's vRouter webinar, where we will introduce the new CLI and NETCONFYANG based management engine. My name is Eva Bonodo, and I will be your moderator for today's webinar. Joining me today is Yann Rapaport, CLI's VP of Product Management. You can ask your questions using the Q&A button at the bottom of the page. We will answer the questions at the end of the webinar in the order that they are received. Let's get started. I will now turn it over to Yann.
Thank you, Eva. Welcome to this new webinar where we'll give you an overview of our brand new management engine and CLI based on NETCONFYANG. We at GWIND have decided to completely revamp the management of our vRouters to provide our customers with the programmable APIs to easily integrate with third-party orchestrators, monitoring systems, and management tools. Before I deep dive into this, let's say a few words about GWIND. GWIND is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing. We make high-performance networking software with deep expertise in telecom. Our flagship product is vRouter software that has been deployed globally for over a decade. And for those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. In recognition of our innovation, we received an investment from Cisco and multiple awards, including NFV and VNF Products of the Year for our vRouter. This year, we won a vRouter Innovators Awards from IDC and SDN Deployment of the Year for our vRouter within our service provider customer EOLO's network. In this case, EOLO replaced hardware routers with SDN routers. We will talk more about this use case in a few minutes. Our vRouters are available in 3 different software packages for white box networking. The first is our GWIND software, which is source code for Linux networking. GWIND includes complete and modular layer 2 to 4 networking stacks. Here, we help our OEM customers build their own vRouter technology and more, including a full range of additional networking equipment and solutions. The second are software appliances called Turbo Router and Turbo IPsec. These vRouters are ready-to-run appliances for customers who build and operate networks. And the third is virtual infrastructure software for hypervisor networking. These vRouters boost virtual networking and switching performance inside NAV platforms, such as Nuage Networks AVRS and Contron SIM-Cloud. Our software runs on market-leading processors that leverage DPDK for performance, including x86 and ARM. We've been solving networking performance challenges for our network builder and OEM customers who are using our vRouter technology for over a decade now. Our customer list is impressive, with a large global reach, including servicing over 90% of 4G networks in Japan and the top service providers in the US and EMEA and more. These customers use our software with standard tools such as Linux and commodity hardware to solve some of the largest networking challenges in the industry. Let's review the EOLO use case, which highlights pretty well the way our vRouter can work with a third-party management. EOLO is an Italian service provider that we've been working with for 5 years. EOLO needed to provide fixed wireless broadband to its customers in rural Italy. Rather than buying traditional hardware routers, EOLO decided it build its own custom SDN routers using COD servers, Linux, and GWIND vRouter source code for performance. It started the project with GWIND on Tilera servers, and then migrated to the new Intel Xeon Scalable processors on Advantech Whitebox Sky servers with the same GWIND software. As a result, EOLO is now servicing 300,000 customers with a completely flexible SDN router platform that enables a 60% capex reduction compared to legacy hardware equipment such as Cisco hardware routers. As it is software-based, EOLO can customize its SDN routers to evolve for future requirements. To explain why we have decided to rework our management, let's have a look at what's happening in the industry. Both service providers and enterprise customers leverage their existing infrastructure to host numerous and complex network functions and decrease CapEx by running vRouters on shared standard hardware resources. Automation helps decrease OpEx by achieving network maintenance tasks more efficiently. In other words, the IT and networking worlds converge. Centralized management interfaces coming from the data center world are now used to deploy and manage networking applications. This is what I call the next-gen management frameworks. Next-gen management frameworks provide the following features: deployment, license management and enforcement, monitoring and analytics, day 2 configuration, and lifecycle management. The next-gen management framework itself is very likely to be integrated with other frameworks, from legacy NMS to state-of-the-art cloud management systems by way of NFVO, VNFM, and VIMS. Therefore, it has to expose its capabilities through APIs, likely REST-based. And to program the vRouters, the next-gen management framework relies on automation tools such as Ansible and leverages APIs. At GWIND, we are making our vRouter ready for such integration. In the next slides, I will focus on the configuration capabilities of the vRouter through a couple of examples, and I will conclude with a short IPsec demo involving CLI and NETCONF management. Let's start with the CLI. Although next-gen management frameworks rely on the NETCONF API, users need a CLI for fine-tuning and troubleshooting purposes. Plus, our CLI is based on our YANG models and acts as a NETCONF client for our management engine, so it is a good introduction to our management system. As you can see, question mark or the help command can be typed to get help for all available commands at that path in the CLI. These help messages come directly from the YANG model. Completion is provided by hitting Tab. Let's edit the running configuration, that is, prepare a staging configuration that we will commit as the current one. After typing edit running, we see the prompt changes. We just entered edit mode. Let's configure some IP addresses and hostname. Networking configuration happens in a VRF context. Let's enter the main VRF context using an absolute path. We see the prompt is updated. We create an interface. The exclamation mark indicates that the YANG schema is incomplete. This is because an interface definition requires an associated network port. Let's list the network ports available in the system. The show state commands are available from configuration edit mode. We use a command with an absolute path to dump the list of network ports in the system with their corresponding PCI IDs. After binding a port to the new interface, the exclamation mark disappears. We now configure a static IP address. And we go back to the root of the VRF using 2 dots twice to go 2 levels up. Now, let's do a similar configuration on another interface named DP1, but this time we use one-liners to configure the port and enable DHCP without navigating into the interface context. And finally, let's configure a hostname using an absolute path. We can now use showconfig to review the relative configuration. And we can also use an absolute path to review another section of the configuration. After committing the configuration, we can review the state of the router from the configuration edit mode. First, hostname using an absolute path. And then interface DP1 using a relative path from the main VRF context. Let's summarize the CLI features we have just reviewed. The CLI provides standard features like contextual help, completion, and history. It allows to manage configuration files, including start, running, and inactive configurations that can be imported and exported. Browsing is convenient. Users navigate through configuration context as they would browse a file system. Relative and absolute path can be used, which is very intuitive. System state can be retrieved from anywhere so that the user can easily compare and copy-paste state information while editing a configuration. Finally, the CLI is actually a NETCONF client that communicates with the vRouters Yang-based configuration engine. Its common name and statements follow the syntax and the hierarchical organization of the vRouter Yang models. Data consistency is checked against the Yang model so that syntax errors are detected early. This is actually a smooth transition to our next topic. Let's talk about NETCONFYANG. NETCONF is a network management protocol standardized by the IETF. It defines mechanisms to install, manipulate, and delete the configuration of network devices. It uses extensible markup language-based data encoding for the configuration data as well as the protocol messages. More information is available in RFC 6241. Yang is a language used to model data for the NETCONF protocol. A Yang module defines a hierarchy of data that can be used for NETCONF-based operations, including configuration, state data, remote procedure calls, and notifications for network management protocols. More information is available in RFC 7950. Together, NETCONF and Yang provide an API for integration with next-gen management frameworks. Here is an example of NETCONF XML configuration. We recognize the items we have previously configured through the CLI. Hostname, DP0 interface with static IP address, DP1 interface with DHCP configuration. And this is an example of NETCONF XML schema for state, where we recognize the information that was configured previously, such as the DP0 and DP1 interfaces with ports, but also dynamic information, such as the interface counters, or the IP address obtained dynamically through DHCP with the lease information. Finally, let's have a quick look at the architecture of our vRouter 2.0 management, especially in terms of extensibility for our source code users that will add their own data plane or control plane protocols or extend existing protocols with new or proprietary parameters. On top of the Linux and FastPass subsystem, the management engine relies on the Yang data store based on the sysrepo open source project. We have implemented sysrepo services to configure Linux networking for the different features supported in the vRouter in a Python plugin called YAMS for Yang-based management system. YAMS leverages the standard Linux interfaces to configure networking. On top of sysrepo and YAMS, we provide a NETCONF server based on the net2peer open source project. It interacts with sysrepo using the Google Protocol Buffers APIs and exposes the NETCONF API to the user interface. This API is used by our vRouter CLI that is automatically generated from the Yang models. And also, it is available to vRouter users for integration with their own management systems. To summarize what we have just seen, we make our vRouters ready for integration with next-gen management frameworks by providing APIs. These APIs are NETCONFYANG based. Still, we provide the CLI as it is required for fine-tuning and troubleshooting purposes. And for our source code users that extend the vRouter with their own protocols or add parameters to existing services, our management system is extensible. It relies on standards, leverages open source projects and well-known languages, and the CLI is automatically generated when extending the Yang model, as well as the documentation, by the way. Let's now switch to a simple demo illustrating these topics. This demo consists in a site-to-site VPN interconnect use case. We will generate traffic from a host on the first site through a security gateway named GW1. The traffic will be encrypted using IPsec and sent to the security gateway of a second site named GW2 to be decrypted and to reach the destination host. It is a very simple use case that will allow us to demonstrate the use of our CLI to configure GW1 and of NETCONF to configure GW2. It involves IP and IPsec and EKE, of course, but also VLANs and loopback interfaces. Let's dive into the demo. Here is the control center of our demo platform. The two windows in the bottom are consoles on the two security gateways GW1 and GW2, where we can see the CLI prompt with the host name. The two top left windows are the Linux command lines of the hosts that we will use to generate traffic. And the top right window is the Linux command line of the management host that will be used to perform NetConf operations. Let's start the demo. On GW1, we can review the help system. The help command can be called to see all the commands available in the system. Help show displays the syntax and help for the different available show commands. Show followed by tab displays the next available keywords. And show followed by question mark displays the same keywords with the corresponding help from the Yang data model. Let's dump the running configuration using the show config running command to check it is empty. Let's now configure GW1 using the CLI. With the edit running command, we enter edit mode, and we will load the IPsec configuration that was prepared in advance using the load file command. After the configuration is loaded, we can navigate to the VLAN 6 interface in the main VRF, and we will display the contents of the configuration we intend to apply. For that, we use the show config command. We can also display the information without the default values using show config no default. We see that VLAN 6 will be configured on top of the NTFP1 interface. It will be assigned the VLAN ID 6 and the IP address 10.6.0.1. Using show state, we can check that there is currently no data in the system for this VLAN 6 interface. Let's now review the intended configuration for the loopback interfaces. We can do this without leaving the VLAN 6 context by using an absolute path in the show config command. We see that the 172.30.0.1 address will be assigned to the IPsec endpoint loopback interface. Next, let's navigate to the IKE context in the main VRF. Using the show config no default command, we can see the list of configuration items we intend to apply, including the pre-shared keys, the IKE and IPsec policy templates that will be used by our VPN, and the VPN itself, with the security policies matching the clear traffic and the encapsulating addresses. We commit the configuration, and let's use the show state command to check that the VLAN 6 interface has been configured in the system. Note that we do that without leaving the edit mode, so that if we need to adjust our configuration, we don't have to navigate between operational and edit modes to alternatively review the system state and modify the running configuration. The VLAN 6 interface is properly configured with the expected IP address and VLAN ID on top of the NTFP1 interface. In the show state output, in addition to the static configuration that we have applied, we can see the interface counters information, displaying incoming and outgoing bytes, unicast packets, discarded packets, and error packets. Now, let's switch to GW2 configuration. We will apply a similar symmetric configuration, but this time using NetConf. In the management console, we review the NetConf schema used to retrieve the VLAN configuration, equivalent to the show config CLI command. This is a simple XML file that we will use with our NetConf client to send a get config request over the network to the NetConf server running on GW2. The result is received and displayed in JSON format, showing that there is currently no information configured for VLAN interfaces. Next, let's configure VLAN 106 using NetConf. Here is the XML data that configures the interface with the 10.106.0.2 IP address, VLAN ID 106, on top of the NTFP2 interface. We send this data as an edit config request to the NetConf server running on GW2. Then, we send a GET request again to review the configuration, and this time, we see the information is properly configured into the system. Let's do the same for the rest of the configuration. We review the XML data that will be sent to the NetConf server. We can see the configuration of the interfaces, configuration of the ports, VLANs, their IP addresses. We can see the IPsec and IKE templates, the VPN that is symmetric to the previous one we reviewed previously. And finally, we see the routing information. We apply this configuration and are now ready to process and encrypt traffic. While traffic will be running, we will dump in several places in the system to check clear and encrypted packets. On host 1, let's prepare the ping command that will generate the clear flow towards host 2. On host 2, let's dump the ICMP traffic. We expect to see clear text ICMP packets. On GW2, let's prepare to dump traffic on the interface connected to GW1, that is, at the end of the VPN. We expect traffic to be encrypted. We do that from the CLI using the show traffic command. We will limit the output of this command to 20 frames for the purpose of readability. And we do the same on GW1, on the interface entering the gateway from host 1. Traffic should be clear text. As expected, we see the ping goes through, enters GW1 in clear, is encrypted between GW1 and GW2, and received in clear on host 2. This concludes our demo, where you see how easy it is to configure an IPsec VPN with our new management, whether it is using the CLI or NetConf. And now to Eva for the Q&A.
Thank you, Jan. I kindly remind our attendees that you can use the Q&A button to ask your questions. So now let's answer the questions we received. First question is, why would someone use NetConf instead of CLI?
So as we explained, the obvious answer to this is for automation and integration with management systems. Actually, it's also possible to integrate with orchestration and management systems using the CLI by just writing some CLI plugins for these systems. But NetConf is a standard. It's model-based. It's a programmatic interface, and it's much faster than directly using the CLI. And that's why the industry is moving to this standard-based interface.
Okay. Another questions we received is, which management framework have you integrated with your vRouter with?
Yes, so we have done different types of integrations with the standard NMS, like for example, Nagios. We have also integrated with more complex systems, VMware, OpenStack, with our partner Cloudify. And of course, since our software has been provided to tier 1 equipment providers for the last 10 years, these people have integrated with their own management framework. There have been also integration with OpenDaylight, and we have our customers, Nuage and Contron, who have integrated our technology with their frameworks.
Thank you, Jan. We received another question. Do you provide monitoring functions?
Yes, so this webinar was focused on the configuration part, but we actually have monitoring functions in the system. So we have legacy monitoring functions. You can monitor using our CLI and NETCONF interface, just get some atomic statistics from the system. We also support S-Flow, we support SNMP, and we also support telemetry. That is, we are able to stream information from the system to a time series database that can then be displayed through a front end, like for example Grafana. So we have pre-integrated with InfluxDB and Grafana. Our pre-integration is available on GitHub. It is public, it is an example, and dashboards are available.
Thank you, Jan. Another question. Will there be a script to convert V1 configs to V2?
Yes, so I understand the question is whether if there is a change in the data model, will we provide scripts to move from one data model to the other? So it's something we are considering. What we will do for sure is that we will provide compatibility between the two data models. We will be able to handle both V1 and V2 for a number of releases. And we will guide our customers to move from V1 to V2 when there is a change in the data model. How we will guide our customers is still being thought about. So maybe a script, we'll see. But what is sure is that we will be able to handle V1 and V2 data models in the same releases to make sure our customers are not blocked if there is a change in the data model.
Very good. We have more time for questions. So another question we received is, does your management frameworks apply to bare metal and virtual machine deployments?
Yes, so our vRouter is pure software. It natively supports bare metal and VM deployments. So it's just part of it.
Okay. Thank you, Jan. If you like what you saw in our webinar and would like to evaluate GWIND vRouter 2.0, register to test drive our vRouter 2.0 beta and try our new management at GWIND.com. On our website, you will also find our product information, regularly updated blog roll, and registration for our monthly webinar series. The webinar is now ending. Thank you, and we hope to see you again soon.